atmospheric pressure. This is the Earth, and the Earth is surrounded by atmosphere. Now, this atmosphere is present up to a height of almost 300 kilometers from the surface of the Earth up to 300 kilometers, which is quite some distance. The atmosphere is present. There is air. Now, all this air, which extends up to a height of around 300 kilometers, can you see all this air, due to its weight, it exerts a huge amount of pressure on the surface of the Earth. This pressure is called as atmospheric pressure. And how much is this atmospheric pressure at the surface of the Earth? It is given by this value 1.013 into 10 raised to 5 pascals, which is also called as 1 atm, that is 1 atmosphere. Of course, the atmospheric pressure decreases as we go higher up. At greater altitudes, the atmospheric pressure increases. And once you go more than 300 kilometers away from the Earth, the atmospheric pressure would almost become zero because there is no atmosphere there. It's almost vacuum. Look at certain applications where you can actually see the effect of atmospheric pressure. Imagine a glass containing water. Take a glass full of water and cover it with some plastic sheet or some cardboard or something like that. And now if you reverse it, you invert it, you will find that even if you remove your hand from the bottom, that plastic sheet will remain stuck to the water. It will not fall down, even though the weight of the water is acting downwards. Still, this plastic sheet will remain in contact with the glass. It will not fall. Why does it happen? That's because the air below it, the atmospheric pressure acting from below, keeps that plastic sheet firmly in contact with the glass, which prevents the water also from coming out of the glass. So this proves the presence of atmospheric pressure. Take another example. When you drink a cold drink with a straw, what actually happens? Let's say this is atmospheric pressure which is acting on the surface of that liquid. Atmospheric pressure pressing down on the surface of the liquid. Now, when you hold the straw in your mouth and you suck, this space where originally it was air, when you suck that air, a low pressure region gets created. A low pressure region, we can call it partial vacuum. So due to this low pressure region, what happens is the atmospheric pressure acting on the surface of the liquid pushes the liquid into the straw. Because of the low pressure inside the straw, liquid gets pushed into the straw due to the atmospheric pressure acting here. And once the liquid reaches your mouth, you can actually drink. Remember, this would not be possible if atmospheric pressure would not have been there. For instance, if you try this on the moon there is no atmosphere, there is no atmospheric pressure. So you cannot drink with a straw on the moon. It is just not possible. This is a syringe, which is often used for giving an injection by doctors. How do you get the medicine to rise up in the syringe? When you pull the piston, when you pull this piston backwards inside the barrel, this space creates a low pressure region, okay, partial vacuum in this portion, due to which the atmospheric pressure pushes this liquid, whatever it is, into the syringe. So the liquid rises into the syringe due to the presence of atmospheric pressure. These rubber suckers, which are commonly used in the bathroom, for hanging, let's say, a napkin, how do they remain in contact with the tile? The backside has a rubber sucker, which it's cup shaped. When you press it against the wall, the air behind escapes. And then it can't come out because the atmospheric pressure acting on it keeps it firmly in contact with the wall. So it is the vacuum created behind it and the atmospheric pressure acting from this side which keeps the rubber sucker tightly glued to the tile, to the surface. Uh, a lizard, how does it manage to climb up a wall? The legs of the lizard, the feet, act like rubber suckers. So they remain firmly in contact with the wall due to air pressure. Okay, so all insects who are able to climb up a vertical wall, they do it because their feet have this suction kind of effect, rubber sucker kind of effect. So they are firmly able to hold on to the surface. They don't fall down. Look at this crushing can experiment, which is used to demonstrate atmospheric pressure. Take water in a metallic can, keep the mouth open, and place it on a burner. When the water boils, steam which is generated due to boiling, that steam pushes out the air inside this can. So the air goes out from here. So this space inside the can contains steam, or you can call it water vapor. Now close the mouth tightly with a cap and pour cold water on that can. Pour cold water. We know when cold water is poured on steam, it condenses. So the steam present here again gets converted to water and the water goes back into the water here. Now, because the steam has again become water, a vacuum is created over here because air has already gone out. Now, because there is no inlet for the air to come in, we have closed the cap tightly. So this metallic can gets crushed. It crumples and it gets crushed. That's because the atmospheric pressure from the outside and the vacuum inside causes the can to get crushed. So this again proves the existence of atmospheric pressure. Siphon is another example to show the existence of atmospheric pressure. There is one container containing a liquid placed at a greater height and another empty container placed at a lesser height. Okay. Now imagine a rubber tube is dipped in the container which is placed at the height and just suck out the air from the tube so that the liquid would rise in the tube. Okay, let the liquid completely fill the tube and then drop the tube in the lower vessel. You will observe that the air pressure acting on this surface will push the liquid through this tube, and when the liquid in the tube starts falling in the lower container, okay, when the liquid falls, it creates a kind of vacuum due to which more and more water continues to fall, and you will find that the water level in the upper container reduces and the water falls in the lower container. The siphon is again due to the presence of atmospheric pressure. It is atmospheric pressure which pushes the liquid from the upper container to the lower container. So all these examples prove the existence of atmospheric pressure. In the next section, we will learn how to measure atmospheric pressure. What are the instruments used for measuring atmospheric pressure?